Welcome to our week 3 video. Today we're going to be talking about the nervous system and everything that is associated with it. So we'll start nerve system. Nervous system is composed of two central parts. We have the central nervous system, and this is mainly just the brain and the spinal cord. And then on the other side, we have the peripheral nervous system. And this has different compartments. We are not going to talk much about the central nervous system, but we have two parts. This is the somatic nervous system. Just going to abbreviate. And so this is all skeletal muscle, an important part is it's all voluntary, meaning that you have control and decisions whether you're going to use it or not. But what we're going to focus on is the autonomic nervous system. The autonomic nervous system, as the word auto, it operates without our control. This is the things that keep us alive. So when we're talking about muscle, it's mainly smooth muscle and cardiac muscle. And it is non-voluntary. Alright, so the two main parts we're going to talk about. So this can be divided as autonomic nervous system. It can be separated into the sympathetic nervous system or the parasympathetic nervous system. So our sympathetic nervous system, this one is, I will change this to blue so we can tell a little bit of a difference here. So this, the sympathetic nervous system, is our freeze, fight, or flight. So this is in any situation, so a life-threatening situation, or we're stressed out, or anything that correlates with that. Our peripheral nervous system is more of the chill. This is our, they call it the rest and digest. So this functions a lot more on our daily basis on things that we're not stressed out about, things that help us relax a little bit more. And they both function together as we need them to. Neither one will function more than the other, but they'll go back and forth depending on our situations and what we need to get done within our body. So these two occur on different parts of the body. So say this is our brain. Poorly drawn brain. Well, that's okay. So the peripheral nervous system is called the craniosacral. And so this is composed of C2 through C6 and also S2 through 4. Craniosacral division. And the sympathetic nervous system is composed of T1 through L2. Oh, I drew that on the wrong one. Oh, I just erased everything. There we go. That's in the right place now. So with it being T1 through L2, this is called the thoracolumbar division. And so as these are, well, I'll just draw this out for you. So, this is how synapse occurs on the peripheral or the parasympathetic nervous system. So it has a long preganglionic synapse and a shorter unmyelinated postganglionic synapse. And this uses a neurotransmitter called acetylcholine. That's how I'm going to abbreviate it, acetylcholine. Ooh. And sympathetic nervous system has a shorter preganglionic, still myelinated preganglionic synapse and a longer unmyelinated postganglionic synapse. And this as well uses that acetylcholine on the first one, but then it uses catecholamines. I'll write that word. Catecholamines. So you've heard these before. This is things such as epinephrine, norepinephrine, and also dopamine. So I will just put epi for epinephrine. Okay, so what this does is it activates alpha 1, alpha 2, beta 1, beta 2, and beta 3. So these are the different subunits. These subunits. This epinephrine or acetylcholine, they will bind to the G protein and cause that conformational shift, and this subunit will be the one that leaves and activates something within the body. So on a parasympathetic, this one is all the M's, M1, M2, M3, M4, and M5. And these have different effects on the body, as I said before. So what we call these, we classify these because they use that catecholamine. We call these adrenergic, meaning that they do use these subunits and the catecholamines. Beta 1. And on the other side, on the parasympathetic nervous system, we call these cholinergic because they're using that acetylcholine. And these subunits, they actually have impacts on these neurotransmitters. These IP3. So beta 1 is going to increase IP3. Same with the odd numbers on parasympathetic. While the even will decrease in cyclic AMP. These over here though on the other side. So alpha will decrease in cyclic AMP, while the rest of them will increase in cyclic AMP. And while we're talking about these adrenergic, so they will also have different catecholamines in which they have a preference for. So, alpha 1 prefers and reacts best to norepinephrine. They'll still react to each other. So this alpha 1 will still react to epinephrine, but it will react greater with norepinephrine. Same with alpha 2. Beta 1 is equal between epinephrine and norepinephrine, has the same effect. So beta 2 actually has a preference for epinephrine, and beta 3 has a preference for norepinephrine. So what effects do these have? So alpha 1 is very impactful because it dilates the eye, which we call mydriasis. It also has a big impact because it causes vasodilation. Oh, I'm sorry. It causes vasoconstriction. Beta 2 here causes vasodilation. And it also works on the lungs to dilate the bronchioles. Beta 1 will increase the heart rate. While the rest and digest side will find the opposite. So all of these, any of them, will decrease the heart rate. And one will cause will constrict the pupil, what we call meiosis. It also causes salivation. And then the M odd, so any of the odd 1, 3, or 5 stimulates sweat glands. I'll teach you about sweat glands real quick. Sweat glands, it's really interesting because it is a part of the sympathetic nervous system, but it's a little bit different. It's all unmyelinated. Moves to M-odd as we talked about, but it only uses acetylcholine. So this is general sweat glands. And the only other thing that we missed here is all of these M's will increase the GI tract, causing that digestion. Alright, and then the one big difference between these two sides, between this, well, actually, the sympathetic and the parasympathetic. So the sympathetic does some interesting things. The parasympathetic, it just goes straight to the muscle that it's acting on, the muscle of the organ. So I'll teach you a little about different types of sympathetic nervous system synapses. So we have spinal cord. In the thoracic part of the spinal cord, we have these lateral roots. And this is where, I'll mark this right here. This is lateral root. And so we have these different pathways coming off the spinal cord. An important part we have here is called the sympathetic chain ganglia. We have another one, I'll draw a different shape, I'll draw a square. And this one is called the collateral ganglia. So these are two different places where synapses can happen. So we'll draw these different examples. So we're always going to start here in the lateral root. This first one will come over and it will synapse right in the sympathetic chain ganglia, and then it will continue unmyelinated until it goes to the hair, sweat glands, the skin, and the blood vessels. This is what we call the spinal nerve. Our next example here, once again, we'll start here in the lateral root and we'll go through the sympathetic chain ganglia, but it won't synapse there. It's going to synapse in the collateral ganglia. And then off into the organ in which it is innervating. So we call this splenic nerve. And our last one is actually a special example, a little bit different. So I'll try drawing a kidney. This one will go through the sympathetic chain ganglia, also through the collateral ganglia, but it will come over here and it will synapse right on the top here. This is called the adrenal medulla. The adrenal medulla is where most of our catecholamines are produced. And so that will activate that process and then we will produce more catecholamines. Alright, let's look and make sure that we made it through everything. So we talked about the central nervous system, talked about the somatic and the autonomic, the parasympathetic and the sympathetic, where they come from, where they go, where they're located in the spinal cord, their neurotransmitters, their receptors, and their actions, what they're in charge of, and what they do. We talked about cholinergic with the parasympathetic nervous system, and the adrenergic with the sympathetic nervous system. And then lastly, we talked about the mechanism of the receptors with the sympathetic nervous system. Thank you for watching the video, and we'll see you next week.